Okay, guys, so last section of notes for you in this chapter, and then I will be back Tuesday. We will all be back Tuesday, and we can review Tuesday, and then your test will be Wednesday. So, El Niño and La Niña, you guys who take Spanish know that it means the child, so I guess the girl and the boy. Um, and they are part of this oscillating cycle. Now, we can be in a normal period where we aren't experiencing El Nino or we aren't experiencing La Nino, and it's part of the ENSO, which is the El Nino Southern Oscillation Cycle. And so um, it's either happening one or the other, or it's not. And then there's like a percent chance that it could occur. I don't believe that we're going to enter into an El Nino this year. So that means that obviously weather patterns are more predictable. This will play for you guys. Okay, so just in case that video does not play, I will also link it below, and it's one that I would definitely recommend watching again because there was a lot that they explained in a very short. So there's a link, but like I said, I'll also link it below in Canvas. All right, so first thing to understand about these cycles is you've got to understand what a jeer is. So a jeer is the circulation in the ocean of this water. And you've got all sorts of different currents, like, the Gulf Stream is what's by us, and it pushes warmer and cooler waters around the ocean. So when these waters get pushed either by winds or anything like that, typically surface winds, you hear about these a lot with hurricanes. You have what's called an upwelling, and it kind of makes sense. The word it's this water that's pushed back up to the top, and it's cooler water, and it's also nutrient rich water. So really good for fishing for you fishermen. But this happens a lot during hurricanes, and if you're like glued to the Weather Channel like me, whenever we have a hurricane, they talk about the upwelling, and upwelling is good if you're expecting a hurricane because you've got that cooler water that's going to help that hurricane to kind of start to dissipate because they need the warmth, they need the energy to be so powerful. So here is where all these warmer waters are right off the coast. And so you can see how these can get pushed around with the jeers and with the surface winds. And how sometimes things can change for us. So upwellings occur in these two conditions. So either far from shore or along western coasts of continents, and then, like I said, of course, during hurricanes. And here you can see just kind of that pattern that it's going to take. And then a lot of that phytoplankton is going to be pulled up to the top, which is going to also affect the migrations of fish. So fish are going to go where the food is. So when that pattern changes, that's why it can affect the fishing when you have an upwelling. So here's just another diagram of another type of upwelling. I don't think the boxes on your paper totally covered it. So I think all you have to do is write down that the warm surface layer is blown offshore, and in that box, and then you need to know that the cool water upwells from below, and that's that diagram on the left. Okay, so El Nino and La Nina occur based on what the trade winds are doing. Okay, so when the trade winds are weakening, that's El Nino, and that's what causes that cool water to come up to the top. And definitely fill in the northern trade winds and southern trade winds, and then on the bottom you should know that this is happening at the equator. So obviously northern is going in the northern hemisphere and southern is going to the southern hemisphere. Okay, so you may want to pause it here and just fill out your packet. Okay, so if you're looking at these maps, I'm more focused on like the United States because that's where we live. But it happens, the upwelling in a normal year happens along the West Coast typically because of the way that the gears are. And so if you're looking at the top picture, that's a normal year, and then the bottom year, an El Nino year, those trade winds have weakened. And now that upwelling's not going to occur because that warm surface water is staying along the top because it's moving, those winds are moving the other direction. And so it doesn't allow that cooler water, nutrient rich water, to come up to the top. So obviously bad for fishermen on the West Coast. And then kind of what's happening around the country. These are the effects. Okay, so you're having warmer than average temperatures over western and central Canada, um, and over western and northern US. So where it's been cooler, it's not as warm. And then for us in Florida, we've got wetter than average temperatures, especially in the Gulf, and then really dry in Ohio and Pacific Northwest. So it basically makes all our weather go wonky, and it's very complex. And then and so here's just another diagram so you can see that it's drier in some places, it's warmer in some places, and wetter in some. Excuse me. And then here's like a side view so you can see what's happening with the winds and how they're going in a different direction, and that's affecting what the ocean water is doing. So super interconnected. And then La Nina is the opposite. So in a year of El Nino, areas that are warmer, now the areas are colder, and you get other things like that. So the main takeaways that you really need. Okay, I do also want you to check out this video, which I will also link below. But the main things that you need to know about El Nino and La Nina, because they are very complex, is you need to understand that it has to do with the trade winds weakening and changing the upwelling, changing that really what those gears are doing. And then they're then, of course, changing the weather for different parts of the globe. And then what are the environmental repercussions of that? It's affecting where the fish are going. It's affecting, when we talked about range of tolerance and we talked about biodiversity, if animals are accustomed to a certain range of temperatures or range of moisture, now they are no longer experiencing that wherever they live. And so it can be detrimental to different populations of all sorts of organisms, because the weather's kind of turned upside down. So those are the main takeaways, kind of an overview of like the winds, the water, weather goes crazy, and then obviously environmental repercussions. Okay, so that's it. Thanks, guys.